Happy 5th Annual IoT Day, and welcome to the Open Systems Media eCast, Embedded Security and the IoT, Challenges, Trends, and Solutions. I'm your moderator, Brandon Lewis, with today's speakers, Dr. Stan Schneider, CEO of Real-Time Innovations, Gil Ryder, Strategic Marketing Manager at Texas Instruments, Rob Black, Senior Director of Product Management at ThingWorx, and Martellus, President and CEO of Libu Systems USA. Today's schedule consists of roughly 50 minutes of presentation with an additional 10 minutes for audience Q&A at the end of the hour. Before we begin, though, there are a few housekeeping items to address, beginning with the features of your viewing console. The Enlarge Slides button will maximize the presentation slides to fill your entire screen. Second, the Download Slides button will allow you to download and print the slides if you prefer to follow along with a hard copy. Next, the Forward to a Friend button enables you to send an email that includes a registration link to this eCast so that friends and colleagues can also attend. The Ask a Question text box allows you to participate in the event by simply typing your question into the box and hitting the Submit Question button below. You can submit questions at any time during the course of the presentation, and we encourage you to do so early and often while reviewing the material. We will address as many of these questions as possible during the closing Q&A, and also if you have a question regarding the eCast operation itself, you can submit those too, and one of our technicians will be happy to assist you. Now for a more formal introduction of our speakers, we'll be leading off with Stan Schneider, CEO of Real-Time Innovations, the Industrial Internet of Things Communications Platform Company. RTI is the largest embedded middleware vendor and has an extensive footprint in all areas of the industrial internet, including energy, medical, automotive, transportation, defense, and industrial control. In 2014, Stan was elected to the Industrial Internet Consortium Steering Committee. With over 100 companies, the goal of the IIC is to develop, test, and promote the standards that are crucial to the success of the next industrial revolution. Before RTI, Stan managed a large Stanford robotics laboratory, led an embedded communications software team, and built data acquisition systems for automotive impact testing. Stan completed his PhD in electrical engineering and computer science at Stanford and holds a BS and MS from the University of Michigan. He's a graduate of Stanford's Advanced Management College. Our second speaker is Gil Ryder, Strategic Marketing Manager of Wireless Connectivity Solutions and Internet of Things activities at Texas Instruments. In this role, he is responsible for TI's IoT cloud ecosystem and coordinating TI's cross-business IoT activities. Gil has held various roles within TI over the past 11 years, including Marketing Director, Director of Applications Engineering, and R&D Manager. Today's third speaker is Rob Black, Senior Director of Product Management at ThingWorx, a PTC business, where he oversees the direction of ThingWorx product portfolio. In addition to his expertise in the Internet of Things, Rob has extensive experience in security, web services, and cloud solutions. Rob's product management and product marketing background includes positions at Exceeda Corporation, RSA Security, 3Com, and Vertical Communications. Rob received his MBA from the Kellogg School of Management and holds a Bachelor's of Science degree from Washington University in St. Louis in Computer Science and Systems Science and Engineering. He is also a certified information system security professional. And batting cleanup today is Martellus, President and CEO of Libu Systems USA, located in Edmonds, Washington, and co-founder of Libu Systems AG, a privately held software protection, licensing, and security company headquartered in Karlsruhe, Germany. Martellus co-founded Libu Systems in 1989 and was the original architect of the company's CodeMeter software protection and licensing platform. He was born in Germany and earned a master's in computer science at the Karlsruhe Institute of Technology. He's lived in the U.S. since 2000. So that wraps up the introductions for all of our speakers, and I'd like to hand it off to you, Stan, CEO of Real-Time Innovations. Take it away.
Great. Thank you very much, and thank everybody for tuning in today. I hope we can together give you a quick overview of some of the exciting developments in the industrial and Internet of Things, and especially in security for Internet of Things. I'm going to talk about data-centric security for the industrial Internet of Things. That's sort of what we focus on. And really what I think the most exciting thing is the what I'll call the smart machine era, what Gartner here calls the smart machine era, which really is the next industrial evolution where There's going to be distributed technology that can change the world in many different ways. RTI's, actually our founding principle is to enable smart machines for the benefit of mankind. And we're very involved in especially the industrial Internet of Things. So everybody's heard of the Internet of Things. The Internet of Things is huge. You all know the numbers, 50 billion plus devices, $19 trillion in value, and on and on. I just want to make a quick distinction because it's important to us. There's actually two, I think, pretty different things out there. The consumer Internet of Things, which is stuff like Nest thermostat, milk that knows when it's spoiled, and garage door openers that know if you have a key to your house in the car. I suppose the Google Glass, I should replace that with a Fitbit or an Apple Watch. But, wearables that are, a lot of the hype is around this. I think most of the value actually is the exciting thing to us anyway, is the industrial Internet of Things, which is a new way to think about infrastructure and for transportation, energy, medical systems, industrial control, and on and on and on. That's really where we focus. And we're very excited about what I think is the biggest thing going in this area, which is something called the Industrial Internet Consortium, which is now 160 companies, I think. I can't keep my slides up to date, adding 2 to 5 companies a week. The goal of the Industrial Internet Consortium is to build and prove out a common architecture that interoperates between vendors across industries and can enable this coming world of a real industrial internet, which is a connected world. This slide's a little bit newer. It says 159. That was as of Tuesday, so hopefully it's not completely out of date yet. But it was actually founded by, industrial giants, GE, IBM, Intel, AT&T, and Cisco. It's now got 160 companies. RTI is very involved in this. I'm actually on the steering committee, which is sort of like the board. But we lead or co-lead the data management committee, the use case committee. Very recently, we actually stepped up to co-lead the security committee. Also, we're very involved with architecture and marketing, and there's many test bed teams out there. Only 2 are public. We are leading or co-leading 4 of those teams, so we're very involved in this. And we've gained some recognition. This is a study done by a company called Opinions that looked at they're a big data company, looked at 100 million tweets and LinkedIn posts and things, and decided that RTI was changing people's opinions more than others. Of course, you've heard of there's lies, damn lies, and statistics. I think, past that, there's big data. But it's it's definitely an honor to be exposed to that. And the reason we got that is because we're out there in many real designs in many industries. Actually this number is getting old too, but over 800 designs across many industries. And also in 15 different standards and consortia efforts. And by a design, I mean, fairly large things, air traffic control systems, cars that drive themselves, planes that fly themselves, large hardware and loop testing environments, underground mining, medical systems, medical imaging systems, medical treatment systems, medical device connectivity in hospitals, big power systems like the Grand Coulee Dam here. It's the largest power plant in North America, very high security and availability requirements. Siemens Wind Power is the wind turbines, big wind turbines. And actually the technology I'm going to talk about started out really its first big win was the Navy. I think I'm pretty sure we're running actually every active Navy surface ship. And typically, the entire ship-wide area network or total ship computing environment. So we have a lot of experience with a lot of large systems. Some of them are very big, 10 million independent data paths, 1,500 kinds of teams of programmers building different applications, and hundreds of thousands, if not millions, of points for SCADA systems. They're big systems. And then, across the bottom, some of the consortia we're in. DDS is a standard, OMG is a systems consortia, the Navy, avionics, consumer electronics, vehicle architecture, smart grid power systems, medical interfaces in the Industrial Internet Consortium. It's a pretty wide array. This is a good overview of the breadth of the industrial internet. So we have a standard that we have actually helped drive and now support called DDS. DDS is a pretty active community. We know of at least 13 implementations out there. And, you know, there's I won't go into protocols. This isn't about protocols. But, you know, it's really aimed at things that have real reliability issues. Great question is what happens if your system goes offline unexpectedly for 5 minutes or 5 milliseconds, at any time at all. You know, if you're doing a thermostat, it might make your house 1/100 of a degree warmer, and it doesn't really matter. If you're doing a, you know, the Western grid power system or air traffic control or a medical system that could kill somebody, it's absolutely critical. And then, you know, performance and scale. Easy way, you know, have you ever said the word millisecond or microsecond? Do you have multiple teams building multiple products that have to work together, or especially across companies? Or do you have, you know, large data sets, 10,000, 100,000 kinds of data values? And then finally, are you willing to take the pain that goes with building a real architecture? You have to put together data models, have data scientists really understand it. If you've checked at least 2 of those boxes, and certainly if you've checked 3 of those boxes, you really should be looking at DDS standard. It's the only thing that really addresses these things directly. I'd like to point out DDS is fundamentally different than the other kinds of messaging protocols out there, in that all the other ones take messages and send messages. DDS shares data. It fundamentally transacts data between systems as its core paradigm. And I don't have time to really go through what that means, but I will just very quickly throw out for the technical people there. One way to think of it is data-centric is the exact opposite of object-oriented. Object-oriented, you encapsulate data and expose methods. Data-centric, you encapsulate methods and expose data. I'll talk about that in a second. But the reason you want to do that, if you actually expose methods and you want to scale to a very large system, it's very hard to do that because you have to call every method independently. It's at least a, you know, a one at a time kind of update, and at worst, every one of those methods could be different. There's no restrictions. With a data-centric technology, you expose the data. The interactions between data is actually set by the standards. It's a fairly flexible set we'll talk about in a second. But now you're actually going to explicitly share that data model. And this scales very nicely. You can take advantage of multicast and have thousands or hundreds of thousands of participants in the system. And the way you do that is by controlling the data flow. And I have an example here from a medical thing, where a medical application where you have devices and a nursing station, maybe a cloud analytics and a supervisory a clinical decision system that's looking at this. And, you know, DDS, instead of sending messages, you don't think of it that way. You think of my job as a device here is I'm going to promise, I will offer to write this brown thing here, which might be a heart waveform, heart beat waveform. I'll write that 1,000 times a second, and it's reliable, and I'll keep it for 10 seconds. There's actually 20-something of these qualities of service. And then the other end, the nursing station might say, hey, I want to, you know, plot that or something for my nurse, but I can only have 10 times a second, and I only want to get the data if the patient's name is Joe. And, you know, DDS system will actually set up a contract between those two things. And I'm sorry for going into so much detail about the underlying technology. It's really important to understand the security model, to understand that DDS fundamentally is controlling contracts between endpoints. And in this case, this matches. It's writing faster than the other end needs, but it will only send 1 out of 100 of these, and it's only contracting for Joe. And very importantly, you can also say, I will only send it to that nursing station if that nursing station has permission to see Joe. And so, you know, data-centric security model just lays on top of that. It's a very complete security model: authentication, access control, cryptography, tagging, non-repudiation. Actually, handles a case of secure multicast. The nice thing about it, if you actually use a data-centric technology to build just this one, there's no code changes. Instead of code changes, you basically write down what the allowed transactions are, and it will enforce that. You know, it has gotten a lot of attention out there. There is a standard. The standard is approved as of last year. It's actually in the finalization this year. It's being tested by some big names in security. I won't go through what they're doing because I can't, but we did get a press release out of these people, which is pretty amazing. They're really testing this architecture very heavily. As I said, it is about DDS entities, authenticating access control. We actually also have other, we support things like DTLS and transport layer security, but this is a much finer level data path security. There's a pluggable architecture. The reason for doing that is there's a standard set of plugins. If you use the standard plugins, then it will interoperate between vendors. We actually had to run our first interoperable test at the last OMG meeting a week ago, 2 weeks ago now. But if you want to have very high security or your own security plugins for authentication or cryptography, you can plug your own into the architecture. It's a very flexible system. This is a quick dump for those of you who are security experts of how actually all the different pieces work, what technology is underlying it. I won't have time to go through this, but you can read that. It'll be in your packet. I would like to conclude with a point that real security isn't just protection. Everything I've talked about here is protection. It's protection and detection. I have a firewall and a virus scanner on my laptop. That's because we want to protect it from the bad guys getting in. We also detect if we've been compromised. And we actually ran a detection test here with Pacific Northwest Lab for an old protocol, unsecure protocol called BNP3. We cut those lines, replaced it with what I've just been talking about, a secure DDS-based protocol. But now since the bus, we can actually go in here and write little scripts that can look for attack vectors. They actually documented their 9 highest, most worried about attack vectors, and when the scripting system was able to detect all of them with a little bit of code. So it's really good security is both protection and detection. I'm going to run out of time, so you can look at your thing and take a look at RTI. I think we've talked about a lot of this. We do have a new strategic consulting service called Fast Tracks. If you want to understand the industrial Internet of Things, we can come in and help with that. All the way from architecture to security and business objectives and things like that. And there's lots more information online. And for those of you who are curious, I've thrown in a few backup slides that you will get in your packet, a little bit more of the data on the security model and the data-centric standard DDS. And back to you, Brandon.
Great, thanks, Dan. All right, now to our next speaker is Gil Ryder, Strategic Marketing Manager at Texas Instruments. Gil, welcome.
Thank you, Brandon. This is Gil Ryder from TI here in Dallas. And I'm going to talk to you about IoT security for embedded devices. So TI as a silicon company looks at IoT security in a very broad terms. If you think of silicon devices that are embedded in end products, they typically include the information from various sources that you want to protect. We call these security assets that are stored in the end product. And some example of assets could be OEM code, OEM IP, user private information, keys and passwords for internet access, and so on and so forth. So as you look at this information that is stored on the embedded devices, attacks on these assets can happen at various levels. So we look at low-level attacks that are done at the silicon level through even die probing, through attacks that are done at the PCB level, at the product level, at the wireless network level for the case of wireless devices, and eventually attack through the internet. Now, most of the attack levels at the bottom side of the chart are common not only to Internet of Things, And therefore, in this discussion, I'm going to focus about securing embedded devices from attack over the internet. So when you think about embedded IoT devices, one of the biggest challenges is that many of them are very, very low-end end equipment based on microcontrollers that have low processing power and have low memory. The other problem in the emerging Internet of Things is that many of the new devices are built by new companies with no experience in Internet and, of course, with no experience in Internet security. So one of the challenges that we see in the market with our customers is enabling a very robust security for low-end products while making the implementation of these products easy for the OEMs. So as everybody knows, probably the most common Internet security protocol in the Internet is the SSL Tls Security Framework. It is used in the Internet globally to protect billions of Internet activities, Internet transactions every day in banking, in e-commerce, and so on and so forth. So using SSL and TLS for IoT can be very beneficial for IoT applications because it uses or it builds upon a proven technology at a mega scale of the Internet. It can also harness the power of a lot of already deployed Internet services, even simple things like email or even Twitter that are using TLS and SSL. It can also use the infrastructure of the public key infrastructure that provides basically the basis for authentication of servers and users on the Internet. So many benefits of reusing existing TLS and SSL infrastructure for Internet of Things. The challenge is that TLS and SSL do require a lot of CPU power. If you look at the three key components in TLS and SSL, which are key exchange, data encryption, and integrity and authenticity of information and users and servers, this mechanism built upon fairly sophisticated algorithms like Diffie-Hellman, RSA, AES with 128-bit to 256-bit, and SHA and SHA-2 with RSA 2048 and over ECC 256. So all of these are fairly complex algorithms that were when they were envisioned and built to be very secure, they were not intended to be used by low-end devices. So just as a quick example here, I picked up three of the key algorithms here, AES 128, RSA, and Diffie-Hellman. And what I'm showing here is the performance of the system that is associated with the performance of these algorithms and how the performance would look like on two typical MCU-based applications. One is a mid-range MCU, 32-bit running at 80 megahertz, and the other one is a 16-bit MCU running at a lower speed. And as you can see, implementing SSL and TLS code on MCUs like this really gets you very low data rates and slow connection time. Moreover, it causes a big problem for power, for battery operated applications, because long CPU activity time that's associated with this algorithm leads to long activity time, and hence drives battery faster. More than that, the other problem is that SSL and TLS software is very complex. If you look at commercial implementations of SSL and TLS libraries, they typically would consume about 100 kilobytes of flash and 30 kilobytes of RAM, typically more than the low-end microcontroller devices have. Also, the software complexity that is really driven by TLS and SSL is fairly large, because now you need to start linking large libraries, you need to start mastering multiple APIs, and finally, the way that these SSL libraries are built today, to really use them, you need some knowledge of how SSL actually works, because you need to execute the APIs according to the right order and make some right decisions based on the feedback. So many people see this and say, okay, this is way too much. I'm not going to implement TLS and SSL in my microcontroller-based application. And in the left side of this slide, what you can see is that many IoT applications that are fairly low-end, and for the wireless case are connected through low-end wireless protocols like BLE. These applications do not run SSL or TLS. In fact, they don't run at all internet stack on the IoT node. Rather, they base their security on a internet gateway that runs the TLS SSL for them. On the other hand, there are more and more embedded Wi-Fi devices and embedded Ethernet devices, and also a new technology for Internet of Things that is called 6LoWPAN that do not need a gateway for Internet communication, and they do need to run TLS SSL on the node itself. So this is where TI brings its new simpling product line that is built to simplify the development of IoT application by taking the functionality that typically sits in all the systems in a high-end microprocessor and integrating all of them into a single chip that also has internet or the wireless internet connectivity on chip. And with that, we also include the TLS and SSL function inside the chip. And we build the performance of the TLS and SSL on hardware-based accelerators that really run very efficiently with no software involved, the key and heavy computational algorithms like RSA and AES. So if you take here an example of how you would use a simpling product, in one case you use a MCU without a simpling, in the other case you use an MCU with simpling, you can see that the simpling really helps you drive very dramatically high performance and lower connection time, and hence also save more power. And the last note I want to make in this presentation is about over-the-air firmware updates. I just need to really stress out how important it is. You've all heard about the Heartbeat and the Poodle and all the internet attacks that were recently found. So security is never perfect. The good thing is that the basic crypto building blocks, the RSA and the SHA and the AES, are fairly secure, and there's no no recent changes or no recent issues that we found with them, but the protocols themselves that are using SSL, sometimes people find either a bug in the implementation or a hole in the real definition of the actual protocol. And for that, it's really critical that the IoT devices will have a over-the-air firmware upgrade option that allows the OEM to upgrade the security protocol in the field in case an issue is found. So just to summarize, securing communication with the internet for IoT devices is very critical. SSL is the most deployed security protocol in the internet, but implementing it requires a fair amount of memory and also processing power. Many IoT devices are low-end and they cannot afford the power that is needed for SSL TLS. But the good news is that the on-chip hardware accelerators and TLS SSL engine that's embedded inside the silicon can fully offload the low-end microcontroller and bring the power of TLS and SSL to any IoT device. And with that, I'll hand it back to you, Brendan.
Great. Thanks a lot, Gil. Before we move on, I just want to remind the audience to keep submitting those questions. We'll try and get into as many of them as we can at the end of the presentation. And those that we don't get to, we'll make sure that the sponsors get back to you with the answers. Anyway, now on to our third speaker today, Rob Black, Senior Director of Product Management at ThingWorx, a PTC business. Welcome, Rob.
Thanks, Brendan. Hello, everyone. I'm Rob Black, responsible for product management here at ThingWorx, and want to talk to you today about some of the exciting things that we're doing with IoT and helping to secure devices. So you could imagine in a IoT deployment where you have a machine, you've introduced it in the marketplace, and now you want to start an IoT project, and you retrofit that device. So you either use existing communication infrastructure, or you take some sort of communication component and add it to the device, and you have a retrofit project out in the world. And now that project's gone along great. Your management has approved kind of the next phase of your project. So you began manufacturing from scratch a brand new IoT solution. That IoT solution goes out in the world, potentially a new operating system, potentially a new protocol, potentially new boards, all sorts of different things that you're operating in your environment or in your customer's environment. And now that project went great. So now you have your second generation manufactured product. Again, new operating system, new protocol, new board. Maybe not everything's different, but certainly some differences. And then finally, you acquire another company, and that company has its own IoT project. And again, different operating systems, protocols, boards. Okay, so you can imagine that the complexity of this grows very quickly. So, what this really results in is that you're going to have many devices with many operating systems and many protocols. And this is, really, I think, stymied a lot of IoT implementations just because managing all this can be a big challenge. Let's add some more complexity to the situation, and let's look at the average age of a machine by type. So you've deployed your IoT solution, and now it's in the field for years and years, right? So I did a survey of various industries, what kind of equipment was, how long was it on average in the field? Construction equipment, over 4 years, airplanes, on average 14 years, and then you can see in the middle of the chart there, dishwashers, clothes dryers, ovens, ATM machines, MRI machines, and put in whatever machine that your organization manufactures and or operates, and I would imagine it's years and years and years, and keep in mind these numbers are the average. So over that time period, what changes in the industry? Well, I'll tell you one thing that I'm sure has everyone here today, and that is there are a lot of challenges with all the different vulnerabilities that are out there for different pieces of infrastructure. So, for instance, specifically with OpenSSL, you have Heartbleed, which is a notable one, but there have been others as well. That one has a logo, so it fits really well on the slide. With the SSL protocol itself, you have Poodle. With Java, you have update after update every every month or every quarter, and regardless of whether or not you use these protocols or software, invariably there's going to be a vulnerability that's going to be introduced while your machine is out in the wild. And so, what is it that your organization is going to do to help prevent this from happening? And the answer is there's nothing you can do on preventing the vulnerability, right? It's inevitability. It's 100% inevitability that devices are going to be vulnerable at some point, given the length of time that they're out there in the field and given the the tremendous pace at which security research goes on. So this has left a lot of organizations puzzled. What is the right thing for the organization to do? Can you, how is it that you could patch everything? Could you release a product that's not vulnerable? Can you ensure that, if you don't use third-party components, maybe that would help? It seems like a very challenging problem, right? And in the IT world, there's a solution. So you can use Windows Global Policy, right? And if you have a data center or a set of laptops, you can push out Windows Policy and update devices with that policy. Everyone gets the restart your computer kind of message every so often to push that out, and there are other ones like this for other operating systems other than Windows. But one of the challenges with IoT is that everything isn't running Windows or everything isn't running like a laptop, right? There are many embedded operating system, embedded firmware. There are all these varieties of operating systems, and there's no good kind of IT management tool for this mix of different operating systems and protocols. So where does that leave you? Well, I didn't bring you. I'm not here presenting just to have no answer. So of course, this is one of the things that ThingWorx can help. So ThingWorx is a solution that brings together systems, people, sensors, devices, products, and industries, and it's an application enablement platform that really stitches a lot of these things together to allow for you to connect to those devices and then to turn them in your IoT implementation into a meaningful application or set of tools. Additionally, it has capabilities where we can help push down content to your devices. And because we can connect to so many devices and such a variety of operating systems and protocols, today we support many different communication protocols to speak to many different types of devices. And what that means is that you can not ensure that there's never going to be a vulnerability introduced, but you can ensure that you can have a pathway for updating those capabilities. So today with ThingWorx Solutions, we have over 1.5 million devices connected to our solutions, and we're really in a position to help deliver a lot of value to companies where we can solve IoT problems for them. And so now from a proof point perspective, you can look at the expertise that we have in multiple verticals. A lot of these companies are very security conscious. A lot of these companies have big IoT challenges to solve, and we help these companies solve those challenges, right? Whether it's the electronics and high-tech space, it's the industrial space, the commercial equipment space, life sciences, or medical devices, we're in these industries solving these problems, helping customers, push out content to their devices, and updating not just security, but configuration and other software, but also solving the security problem for them. So this is something that we at ThingWorx have a lot of experience with, and are obviously looking to help solve that problem for many other folks who experience the same kind of challenges. All right, so now let's talk a little bit specifically about the software management solution at ThingWorx. So we have a solution that's very scalable, that's very efficient, that's very secure, and very flexible. And it's used and deployed today to support hundreds of thousands of devices, pushing out lots of software updates and in a way where it doesn't bring down your network, right? So basically there's a mechanism to ensure that things go out smoothly and you can partition how much is going out at a particular time. It's also very flexible in that whatever kind of software need or whatever kind of update you need on your endpoint, we can help support that. So how does it work? Well, you define a package. A package, oftentimes would be a file or collection of files and some instructions on what to do, maybe roll back instructions if things don't go properly. Then once you define that package, you would check your asset eligibility. So maybe you want this to go out to all the machines with a particular board or running a particular version of software or some combination, only send it out to the blue ones. So you can really, decide what the eligibility is based on your organization's needs. I know we have one customer that basically does this first in the area, geographically they're very close to where they could roll trucks out to, and once that goes well, then they pick the one within the same time zone, and then they push it out worldwide. So basically they do it from, their ability to service it if they ever would need to roll a truck, but there are lots of other sets of criteria that you might want to do that. And then finally is the deployment part. So then those packages get pushed out to those machines. It's done in a very structured way such that only the machines that are that meet the criteria get sent the content, and it's done such that if you have a million machines, they don't all get the package at the same time, right? So it's basically done as you'd specify. So that is a portion of the ThingWorx solution. We have a lot broader portfolio. I thought our software management capabilities really made sense in terms of talking about embedded security and the challenges. One of those challenges we know is updating vulnerabilities. It's the conversation we have with customers again and again, and something that presumably could help your organization solve those problems. If you really want to learn more about ThingWorx and our capabilities and what we're up to, we have LiveWorx coming up May 4th through 7th in Boston. So that's next month. It's really the IoT event of the year, and in past years we've had just a tremendous amount of industry presence with lots of different companies, actual customers who have solved problems, and it's really become very much an industry event. This year, we have Steve Wozniak coming, co-founder of Apple, and so I'm sure he'll be an interesting draw, as well as a lot of other top speakers on the list. And so if you're interested in learning more about IoT, seeing what other folks in the industry are doing and how ThingWorx can help, LiveWorx might be the right fit for you. Thank you all for your time. Brandon, back to you.
Great. Thanks a lot, Rob. Now for our final speaker of the day, Martellus Kite, President and CEO of Libu Systems. Martellus, welcome.
Yeah, welcome. Thank you for talking to you guys. I will talk today again about Internet security, which is Internet of the Things, which coming as new challenges in this whole embedded world. And we see two different directions. There's on the one side the Internet itself, but on the other side also that embedded systems coming more and more to open system architectures. Developers cannot afford from the complexity to make everything out their own, so they have to go on systems which are publicly available, and this is another challenge. We have a solution for integrate code. So the code will be secure, and that's one of the most important parts, because with code you can do practically everything in the embedded system. You take over the control of the processor 100%. And the last part will be the technical implementation details. It's going quite deep in cryptographic details. You have not to understand how that works, but we want to deliver you that we really implemented something which is secure from a cryptographic standpoint. Okay, the internet connection is one of the challenge points, because your system is more or less connected in the internet, like your computer, like your router, like your cell phone. You could have some firewalls around, but the firewalls are typically something your user, your customer, your installer have to install, and you never know how really good they're working. Then The execution codes, of course, when something hangs in the internet, more or less the code gets obsolete and can be updated. And the update of code is a very critical thing. As you know from your PC, you get a lot of faked emails or other messages who tell you, here's a new update, but this is not a new update. It is something virus-like. And this is, of course, a challenge for embedded systems as well. The code could also be modified through a virus. For example, you download the new version for embedded system on a PC, you transfer it from a PC with it's not even in the internet, you bring it with a memory stick to your embedded system, and on the PC it's just modified. Firewalls are a method, what I think it's too difficult and it is not even necessary. Then you have, of course, the weakness in the code itself, because you have, for example, you communicate with another embedded system, and the other embedded system send you some commands, some data with parameters. You not really check carefully if these parameters are valid. Someone sends you, it looks like garbage, but in reality it is some very tricky code who provides code execution by using buffer overruns, as an example. The security challenge open systems is actually relatively simple. All the knowledge you have, how you develop your system, is also available for your enemy, for your hacker on the other side. He has usually all the tools, he has probably better tools, so he can really going deep, analyzing what you're doing before you actually see what you did. And when, for example, when you send an execution file, the file format is well known, so he can try to change this before it's uploaded, which is a static attack. Or he knows how your code runs in the memory space, in the process space, and implant some other code who modifies the execution of your program, what we say is a dynamic attack. All these things are more likely when you have an open system, but don't forget, even when you everything developed by yourself, a hacker is usually very smart and find out very quickly weaknesses, like your parameters are not checked well, even without seeing your code. So the principle of code integrity is actually relatively simple. So we have on the one side the development system, developer, and on the other side the embedded system. The developer has his application finished, binary code. We encrypt this code. For this we use a license key. That's a part of our business. We in the license secure software licensing industry since 26 years. So this is for us a part of it we're doing on PCs every day, but now we're doing it on embedded systems. So we this encrypted file is transferred to the embedded system and cannot run itself without a license key, which decrypts this code in memory and executes it. So to be sure that this code is not a virus or modified on the transfer, we have a verify segment. And this verify segment has additional parameters. And they're coming actually from a private key only the developer has. So the development company provides a private key which never leave this company. And the code is signed with that. So it's a hash of the code. The hash is signed with the private key, and this hash is sent, this signature is sent as one input of the verification process. But you need more, because we don't want the private key sent to the embedded system. Otherwise, the hacker could say, I'm now the developing company. So we create out of the private key a public key. This public key is sent in a standardized format as a certificate in the embedded system as a parameter of the validation process. And the validation process finally says, okay, this code is granted, I can execute it. So when here something would be modified, it would be a wrong hash, it was denied. And when someone else would make this code signature, it would not fit this private key, and it would deny it again. That's the basic principle of code integrity. And we have two advantages. On the one side, the code is authenticated, so it can only come from the developer, the person who owns a private key. And on the other side, the code is also encrypted, so it cannot be easily reverse engineered by a hacker on the way to there, on the system itself, because it's only decrypted running in the RAM. You have new challenges. When you think about this whole system, it looks nice, but it has one very weak part, and this is this verify code itself. What would happen if a hacker just decides, I remove this verify process or I replace it with some fake one? So it's not enough you have to protect your own code, although the loading process on the operating system, which is an open system, has to be modified that is secure. And this is a part of our architecture we do as well. And finally, you come to the system and say, okay, what happened when the loader in the operating system is fake? So you have to start on the absolute low begin when you switch on your computer. And this is a part of our architecture. But let's start what we're doing. So we have an automatic tool. So the developer has it actually relatively easy to create this certified encrypted code by using our tool. So this is the original executable. It has the code, it has a header. We have the keys you need, the keys for the encryption, the keys for the code signing. We have our AX protector for embedded executable protection. And we create then this new executable, which still looks like an executable, but it has encrypted code, it has an extended loader, and it has all these credentials you need to make your code verification. And usually you don't need any source code and definitely no source code modification to do this process. So again, we show here which keys are actually used. So we have for the encryption process, these keys which are create the certificate, and we have on the other side for the validation process then codes to able to decrypt that, but also the signature and the hash. This is just a summary that you see how these keys are really involved. Now to the next part, what we now that's the next challenge is the dynamic modification. I'm sorry, it was a little difficult here to press the next button. The problem is when your code is loaded, it could still be modified. So how we protect that? So we load the encrypted code is on the file. We load this in with the AX engine in the memory. The memory decrypts it. It is validated if it's authenticated. And after that, it runs. What happens now when someone is able to modify this code? For this, we have a security watchdog. So we have a parallel process running, a thread running, who checks if the code in the memory stays authenticated. So there also a dynamic later code modification by buffer overruns and all this stuff is not possible. And back to the original problem of the code integrity, what happened with the loader? So we do integration in the modified loader with the same method. So we have our AX protector, you get the signature and all the same things. So it's the same method again. We're using for your application. We do it also for the loader of the operating system as long as we have access to that. So this is of course usually an agreement with the developer of this operating system. And what we're doing is we have also a forward-backward check. It means here is something weird. Sorry for that. The button goes in the wrong direction. That we had. Okay. So the forward-backward check means the loader of, this is what I explained all the time, it checks if the application runs well. But the application also, after loaded, checks with the certificate of the loader if it works well. And this is a dual-side process which gives additional security. And this is my last slide. this process that the loader checks the next instance, and the next instance checks the instance who loaded this before, we start or actually in the boot process with the BIOS, from the BIOS and the operating system, from the operating system in the application, and vice versa down back. So we have a really authenticated code, not just for your application, but for the whole code which is running on this one embedded machine. And that is actually the end of my presentation. You see here my contact information. It is possibly technology a little difficult. When you have any questions, when you have any doubts, send me an email. It's my pleasure to answer you that. And with these words, I give back to Brandon.
Great, thanks, Martellus. And that will bring us into the Q&A portion of our event. Keep those questions coming. We've got time to get a few in here. And let's start with one for Stan, who led off. Stan, slide mentioned performance to scaling down to milli and microseconds. What's the fastest data update that you've encountered? And can you give an example?
Yeah, so we have lots of systems out there. I mean, the fastest, not quite sure the fastest, I can say some fast ones. We have a medical surgical robotics system that's trying to actually operate on a beating heart. Very high performance feedback loop. Actually, the heart's beating and it's canceling that motion out virtually. So the doctor looks through a virtual reality system, sees a static surface, and actually has a haptic controller, which is a little thing for your hands that you can feel things, and they want to feel a static surface with enough fidelity to feel the texture of the blood vessels as you cut them. And that requires, it's pretty high performance, it requires a 3,000 hertz control loop, so 3 kilohertz, and they want 10% jitter, so that's a 30,000th of a second delivery requirement. So that's about 30 microseconds. That's, relatively small system, and it gets a lot more interesting. You get large systems. Sometimes we have this system called SSDS, Ship Self-Defense System, for the carrier fleet for the United States, and this is an array of very high-performance radars tracking incoming missiles and trying to shoot them down with 1,000 round per second depleted uranium cannons. It's very, I can't tell you the numbers, but it's, now you've got a lot of data. You've got image data. You've got, very high-performance feedback systems. Actually, I run a company called Real-Time Innovations. The best definition of real-time actually came from the admiral that funded that. It says, I can't define real-time, but I can find not real-time. Not real-time is they shoot 24 missiles at you, and you shoot down 23 of them. Which is actually a really good spec. So, we actually, if you really need the hard isochronous networking, there's a new standard called TSN coming out, and most of our systems, including those, actually, we can detect if you haven't gotten that kind of update rate, and if you don't, then you can switch into a fail-safe mode. But with the isochronous TSN coming out, we'll actually be able to support rates like that. With guaranteed delivery.
Great. All right. Rob, here's a question for you. With Heartbleed infiltrating SSL, is there an alternative for a near guaranteed security other than SSL?
Yeah, so no such thing as a guarantee in security. Almost certainly the only guarantee is that there will be future vulnerabilities. I mean, one thing I would say about Heartbleed in particular, that was a open SSL issue, so that's the open source SSL implementation. I believe that open source libraries like that will actually get more and more secure as more people are looking at them. If you look at the open SSL updates this past year, they've made a lot of security improvements, and I think that will continue. So I do think we will actually have a little bit of a reprieve for those situations, but certainly no guarantees in security. A lot of uncertainty. The thing I think that's critical is having an ability to patch, because with no guarantee, if you have that ability to patch, then you will always be in a state where you can push out the latest content and ensure that you and your infrastructure and your customers are protected.
All right. Martellus, here's a question for you. A lot of systems are built by, or may have been built by, former employees who may have become disgruntled, and they know the system well enough to be able to hack it in the IoT. What procedures should you take in that sort of situation?
I'm not 100% sure I understand the question. So I mean, when someone, the code should never modified by the user. It should, even when it's required. So usually the company has to go back to the developer and said, we need this and this bug fix and everything. And then, of course, they get the new version. And what's essential is for this code integrity is when a system is down and needs you replace the hardware, then you have usually a very short time to reinstall everything, which could take a lot of stress and probably some security features or some security validations are not fulfilled. In this case, code integrity makes it extremely simple because you can just install the code which is assigned for that. You could have it somewhere on a backup system, just play it in, and the operators cannot do any mistake with that.
Okay, but do you think that, say, for example, a disgruntled employee leaves for whatever reason, and you're worried about them having access to the code base, do you think it's necessary to redeploy the executable code again, like a separate version of it, or do you think that's not necessary?
So you mean the and the developing side, a person leaves?
Correct.
Is this the okay?
Correct.
Yeah, I mean in this situation, he usually will not take the private key with him. Should he do that, then it would be necessary to replace this private key. He can, and then of course there should be an update available. So there should be then. The certificate has to be updated, and the next release of the software will use the new private key. This is, of course, a critical position. I would say a private key should store in the hardware where you cannot just copy it like a file.
Brendan, just to add on this point, this is Gil here. I just want to say a good security system isn't vulnerable to any knowledge of the code that's used for its development. It's really based upon the keys and all of the crypto algorithms that are underlying. So a employee that lives and is the company, if the security system was built in a correct way, there shouldn't be any problem or any risk. And of course, keys, as we just said, keys can be replaced.
And Gil, here's a question for you, and actually that may be a little bit applicable to some of the other sponsors here as well. But what about edge devices that have limited bandwidth, limited resources? How do you secure these type of systems? Like if I'm thinking industrial or maybe some sort of resource constrained sensor, how are you able to secure resource limited devices?
Yeah, thanks, Bernie. I just pushed back one of the slides for my presentation. Basically, you're talking about two limitations of edge devices. One is the bandwidth to communicate with the internet, and the other one is the complexity of the edge device, and these need to be looked at separately. I mean, from a complexity standpoint, you have the two options that I'm highlighting here. Option one, you can basically avoid the complexity of internet security altogether from the end or from the edge product or the node and loading it on the edge gateway, in which case this gateway must be capable of running good internet security. The other approach is to use architecture like the Simple product line from TI that enables the complexity of the internet security at a very low end devices. Now, on the bandwidth question, I mean, so first of all, I wouldn't get too caught on bandwidth because if you think of the security update, this doesn't have to be like a full iOS updates, for instance, that some of us experience. These could be very small patches that are pushed into the product, and they can be very very small. But yeah, in general, you need. I mean, there's no way around it. You have to assure the ability and enough bandwidth to upgrade internet protocols in the field, because as everybody said, one day a problem or a security hole will be found in whatever protocol is being used, and you want to be able to overcome or to patch the vulnerability.
Great. And unfortunately, that brings us to the end of our time. I know that probably all of our sponsors today can speak to that last one, so we'll make sure that for those that it's applicable to, that we have them follow up. But I want to thank all of our speakers for some great insight here today on embedded security for the Internet of Things. And we at Open Systems Media, Real-Time Innovations, Texas Instruments, ThingWorx, and Libu Systems USA would like to thank you, the audience, for attending and contributing some great questions. Like I said, we'll have the sponsors follow up with you for anything we did not get to today. This eCast will be posted online at the URL shown on your screen within 24 hours, and an audio-only podcast will be made available there as well. You can do a web search with the keywords embedded space e-cast and find all of Open Systems Media's eCasts available for download as MP3s. Thank you for attending, and have a great day.